Thank you, Atul. That was a wonderful introduction. Let me just play this. Yes, it is indeed. I did not put any pictures of fall, but I will do so next time. It is this season is I'm from Mumbai, and in Mumbai, the only two seasons we have is summer and rain. In Canada, there are really, the people talk about different seasons, and there really is different seasons. It goes from -40 to +40, and right now it's getting cooler. It's about 10 degrees, and the colors make you a little bit forget the temperature, because the leaves turn yellow and red, and it's very beautiful. Anyway, thanks again for having me. This As Atul said, systematic reviews are really the mainstay of a meta-analysis. You should not do rather a meta-analysis without doing a systematic review. And the key here is all about the word systematic here. So in terms of disclosures, I do a lot of systematic reviews and meta-analysis. Cochrane is the standard that people talk about, but not everyone in Cochrane likes me. There's a nice story that one day when I'm in Mumbai, we can sit and chat about. I don't have any financial conflicts, of course, with any industry for what I'm going to talk today. And of course, feel free to use the chat function and put in questions. We will be looking at it and answering them. So my job that Atul has given me is to talk about three aspects. And again, they may seem a little bit dry and boring, but it's about data collection. And without good data collection, you cannot really do any analysis. The analysis may seem like fun, playing with the software and crunching numbers, but you need to have the data to be able to do that. So think about the literature search and data extraction as collecting patient data or enrolling patients in a clinical trial. So it is really key. Without enrolling patients in a clinical trial, you cannot assess if a therapy is useful. This is exactly what we are doing here in a systematic review. So in terms of the search, again, the search has to be very systematic. If you're not really searching properly, you're not going to find everything that you need. And what do I mean by this? Again, so we keep talking about systematic, and you may wonder what is systematic here. And as Atul said, it is not a narrative review. A narrative review is often cherry picked. You may find 5 different narrative reviews. So on ACE inhibitors and angiotensin receptor blockers and kidney transplant. Even now, if you read a narrative review, most of them will suggest that you should be using these drugs. They are wonderful, and they will cherry pick some observational study or one trial that fits their belief. You're not allowed to do that if you're doing a systematic review. You're looking for every single piece of evidence that is there, depending, of course, on your inclusion-exclusion criteria. And just because you do not like a study or you do not like the findings, you're not allowed to exclude it. You're also searching, you're not just saying, oh, I remember this. Yeah, there was that study published by Dr. Mule and that one published by Dr. Rajapurkar, and include those two. No, you're supposed to search, and you're supposed to include everything that fits your criteria. And you have to include it whether you like it or not. That's the systematic part of this systematic review. So what does it mean by being systematic? So, you're applying inclusion and exclusion criteria, not again for the patients, but for the kind of studies you're including. So this applies to the PCOTs, the population, the intervention, the principal outcomes, but also to the study design, the publication date. You may say, hey, we have looked at this in the past, and now we are only interested in the last 10 years for whatever reason. The language. And study selection is actually one of the major sources of disagreement among meta-analysis. People will say, oh, we only included studies where perioperative MI was the outcome of interest, and that will show that CABG is worse than doing an angioplasty and stent in coronary artery disease. And again, there are tricks that you can play. So whenever you're reading as well as performing a systematic review, make sure you look at these inclusion-exclusion criteria properly, because that will explain why, hey, there was this big trial that showed a certain result that the authors did not want to include. But hey, the outcome was different. So let's, nicely exclude that by being very careful or selective in using a certain outcome. In most cases, you want to be very inclusive, unless you have a good reason to be exclusive. And the choice has to be objective. It is something that if I do it today and you do it 6 months from now, or Atul does it next year, it should come up with a similar answer. And again, it's not based on the desired outcome. So you're not going to pick uh, something that you want to find and include the outcomes accordingly. And you should be making them now. So it's really important, and we don't talk about it in the slides itself, but the push now is that all systematic reviews should be registered. So there are registries. For example, there is something called Prospero, where you're supposed to register the systematic review protocol. And in that protocol, you're supposed to say, hey, this is what we are going to do. This is going to be our search criteria, and these are the outcomes we are looking at. And this is supposed to be done when you're planning the systematic review. It takes some time for this registration to go through. And more journals are not accepting papers if they are not registered on this registry. So again, that is sort of a check on you to make sure you're not making up stuff after you looked at the data and said, hey, this is the study we want to exclude, so let's change our criteria for that. This applies to the search strategy. It applies to the inclusion and exclusion criteria as well. Now, what kind of evidence can we include in a systematic review? So there could be sources of published evidence. For example, mostly we talk about experimental studies that are randomized clinical trials, but they could be observational studies if that's what you're interested in. It could be case studies and case series as well. If there is something that there are no RCTs and you're going to pool together the case series, that's completely legitimate. It's a little bit harder, but it's definitely possible. And do you want to include abstracts, or you don't want to include abstracts? So people often exclude abstracts, but for some reasons, in some situations, you may want to include them. So again, these things are something you should be deciding a priori. Editorials and letters to the editor. Now that is, usually people do not include that. That's not really having data. So publications include a lot of things, but these sometimes can be useful to find other papers. And are you looking at animal studies, or you're looking at human studies? And are you going to look at other reviews and systematic reviews and meta-analysis? So all sorts of publications are possible. So, and there are filters for each sort of publication. So you can use them to filter in or filter out those kind of papers. I would suggest that it's good to include reviews in your search itself, because the reviews can, if you read those reviews, they can identify a few papers that you may have missed in your search. Animal studies, again, you may want to do a systematic review of animal studies. So if that's your purpose, it's completely legitimate. Otherwise, it's a good practice to exclude all those studies. And should you be including unpublished data? That's the other aspect. This is what you want to end up with. You want to end up with a lot of papers. So how do you get to that point? On the methods, what kind of sources are you looking at? So Medline is the National Institute of Health, the American National Institute of Health, National Library of Medicine. And there are a couple of search engines for Medline. There is the Ovid search engine, which is less well known and for which you need access through, it's a paid subscription through a library that you usually need. Pubmed is the one that's freely available. And over time, Pubmed has actually improved. And I'll show a few screenshots of examples of doing how to do a good search by using Pubmed for a systematic review. There's another database called Embase, and there's the Cochrane library. So the Cochrane library has, what they do is there's a bunch of people who are looking at published evidence, and if there are trials, the Cochrane people will identify them as trials and put them in a registry called the Cochrane Central. If it's a systematic review, they'll put them in the systematic review. So they have a bunch of registries. It's not useful if you're doing observational studies, of course, but if you're looking at trials, the Cochrane Central registry is a useful source, which you should include. And these three are the most common ones used when you do a systematic review and meta-analysis of randomized control trials. And it's mostly acceptable if you restrict yourselves to these three. But there are some other sources. There's Web of Science, and there's Google Scholar. There's something called Sinal. So there are other sources that have come to be, and Google Scholar is a little bit tricky to use, because it's very, very sensitive. If you search for anything in Google Scholar, even if you do, if you put in search terms, you end up with a few 100,000 hits, and you don't have time to go through 100,000 papers. So be careful if you're saying you're going to use Google Scholar. So what about the search methods? So there's something called mesh terms. There are the medical headings, subheadings, and you can explore them. And I'll show some examples again of that. Should we be using the keywords or a full text? And there are some methodological filters that you can use to identify, observational studies or case control studies or randomized clinical trials. And they are most useful for identifying randomized control trials because people have used them and they have seen how good these filters are. Are they good at filtering out the noise that you do not want, but are they still specific enough, sensitive enough to include all the trials that you want to include? And again, coming back to the inclusion exclusion criteria for your search methods. And there are additional sources. It's not just, Medline, Embase, and all. So there are existing reviews, which I would highly recommend you read. You always find some in the bibliography of existing reviews that you may not have checked. If you have got a paper that you are including, then you cross-check the citations. Look at the other papers that this paper has cited, and go and include them. It's completely legitimate to do that, as long as you cite that properly. And you can do a hand search of key journals. So let's say it's a kidney transplant topic, then clinical transplant and transplant proceedings and American Journal of Kidney Disease, perhaps AJKD, JSN, CJSN. It's reasonable to look at those journals and keep going on. You can ask people. We actually found a paper by just someone telling us, saying, "Oh, this paper is not included." I said, "Okay, go ahead." Experts can tell you about important papers that your search may have missed. And you can search the registry for pertinent studies. And what do I mean by that? So you can go to a registry such as clinicaltrials.gov and do a search. And this is especially useful when there is a topic, say, if you're talking about COVID, then it's really important to look at that, because this is an evolving topic where new studies are being done and coming out very fast. So you can search these registries. Clinicaltrials.gov also allows for publishing results. So it also gives you a sense of how many studies are there that are ongoing, which are going to come out. Sometimes you may realize that, hey, you're doing a systematic review and there's this large trial going on in England, and it's going to come out. It looks like they're finished enrollment and they're closing next week. So if the results are going to be available in a few weeks, it may make sense to wait for that to be published to extend your search time and do that. Otherwise, your systematic review may get outdated as soon as it's published, if there is this large study that is going to come out soon. And suggestions, so don't rely exclusively on computerized searches. There are sometimes you have to be careful, is that some papers, some authors may have published multiple papers from the same study. And and the author name may not be, the first author name may not be the same. It may be different. So this is something that you often, you may pick up initially, or you may pick it up later while you are actually putting the data together. So it's important to exclude them. Otherwise, if you're double counting them, and you'll be giving extra weight to that study. And go beyond abstracts, not just the abstracts when you're doing this. So, you're on a journey, you're looking at systematic reviews, and how do you find exactly what you want? It's almost like a treasure hunt sometimes. This is one example from a published literature. And why am I saying that you should just you should not restrict yourself to Medline? You may think that, there is one database, isn't that enough? Well, this shows you that it is not enough. They looked at many. This was looking at epidemiological studies, observational studies, where it becomes even more tricky to do a search properly. Um, and as you can see, different number of papers were found with similar search terms. For example, Medline, they found 537 papers, whereas with the Embase, they found 881, out of which 65 are relevant and 66 for Medline. But there was not a significant number of overlap with all these. So there were some unique papers found, so there was one paper found in pre-Medline. So pre-Medline refers to papers published before 1966, which would have been missed if you had restricted yourself to Medline. There were two papers found in the last column shows you that. So there were two papers found in Embase, which were not found in any other database. There were three papers found in Biosys, which is not a search database that I ever use because it's not great for trials. But in this case, it was really useful. So there are all these other places that you find papers, and this is important if you want to make sure you're not missing anything. And papers are being published in in all these kind of sources. And lastly, you look at that last row. There were two papers that were found by looking at other meta-analysis and by doing a hand search. So don't discount all those other methods of really being careful and finding out papers. And Atul talked about publication bias, and what that happens is refers to the fact that small negative studies are less likely to be published. So you do a study of 45 patients, and you find that, hey, ACE inhibitors didn't do much. You send it to any JM, and that they are not interested. Of course, you send it to JS, and they are also not interested. And you send it to CJS, and they are not interested. You send it to AGKD, they are not interested. And you get tired of reformatting the paper, and your fellow who had done your resident who had done the search, he passes and he goes into private practice, and you are doing other things and you don't have time. It remains in unpublished. So this is something that is often the case, that many papers don't get published. So publication bias, and to find all these papers is important. So some of them may have been published as an abstract, presented at a conference, but never went on to get a full paper. So you contact those authors if possible, if you can find them, and try to get extra data from them. You can also find some of these studies in the clinical trials registry. Now, since about 1998 or 2001, NIH mandated that all trials should be registered in the clinical trials.gov registry. So that's a really useful source where you can look at trials that have been, someone started those trials. Often it will say whether the trial has been finished. So you know that it has been finished, but if it's not published, then you can try to contact the authors and find out if anything has been done. That could be an issue. For example, this is an older example of survival ratio for multi-agent therapy in ovarian cancer. If they looked at published studies, which were 16, it looked like there was something there. But if they included 13 extra studies that were registered but not published, which are negative, as you can see, so that shifted the risk ratio, the odds ratio from 1.16 to 1.05, and showed less of an effect. And this is a common problem of publication bias. So you wrote registries, if they exist. You write to scientists working in the field. And of course, we'll talk about in the next session about doing funnel plots, which and some adjustments that you can do and impute studies. They are not perfect because they are just running analysis and numbers to see. The software is looking for missing data, and it relies on certain statistical assumptions. There's, of course, the language bias that Atul also alluded to. So trials are more likely to be published in an English language journal if the results are statistically significant, right? If you're doing a study from, let's say, from Iran, and it's not significant, then it's less likely to get published. It may a Korean article. There's a huge Korean database actually of studies that are published in the Korean language. And if it's not significant enough, they may not make it to the English language journal, and you may miss that. Though David Moore has done a study showing that it doesn't seem to matter too much, but it depends on the topic area. In some topics, it may be possible that there's a huge non-English literature that you may miss. And an exclusion of these literature may sometimes lead to exaggerated benefit. And though we find publication bias, there is a difference of opinion about what to do. And you will not find many, the funnel plot is not easily highlighted, but I would say that it should be, if it's just good practice. What about the time? So Medline goes back to 1967. So if you search on PubMed using either Ovid or Medline, it goes back to 1967. If you need to go back to older Medline, you have to use pre-1967. You have to use a different database, which is exclusive for that older search. Now, again, it may not matter, right? ACE inhibitors and transplant before 1967, there were not many kidney transplants that were done, so it doesn't matter to you. But depending on your search, this question may or may not matter to you. And Embase goes back to 1946. So this is, one example. What you could do, you're looking for trials in PubMed, you just type randomized clinical trials, and you can see how many you get. What I would suggest you do is, there is an advanced button. You could press on that advanced button, and that takes you to this screen. And if you click on the all fields, you will find a bunch of options there. And if you scroll down, you can find, you can search by author, last name, author first name, date, and certain filters, as well as certain keywords or mesh headings that you can search for. So in this case, you can see if we ask PubMed to search for randomized controlled trials, you end up with 659,371 studies. But then there are filters. So this is a filter that can be used in PubMed, where these are the options. So in the publication type, you can put in clinical trial. There is something called groups. So you can use title or abstract in the groups. You can use placebo or trial or random or drug therapy. All these are things that are words that are often found in RCTs. So you include these in your search term. And again, you note the in capitals or. So, any of these terms are acceptable. If you do and instead of or, then you're going to find very few studies. So make sure you're using or in this filter, and I'll show an example of that. And again, there is animals is a mesh term, so you can exclude animal studies very easily, and include humans as a mesh term, which again helps narrow down your search. Because if you're looking at 659,000 studies, it will probably take you a few years just to finish your search, and by the time your search, systematically you make it outdated. If you're using Ovid, it's a slightly different search engine. So this is one filter that we have commonly used. And again, the terms, it's a different database, so the terms are slightly different. So let's try, in this case, I'm not used the filter. I said, hey, it has just a randomized clinical trial. So let's try that and do English language. So it narrows down your 659,000 to 620,000, so about 40,000 non-English studies were excluded. That's still a large number. So let's use that filter, and using that filter again, this is exactly what I suggested we should be doing. You put in each term from that filter. So you say randomized, clinical trial, groups, placebo, trial, random, drug therapy, in the mesh subheading. You put an animal, and then what you do is you can combine these terms. So when you're combining, you say, hey, add clinical trial, groups, placebo, trial, and random using or, and then add you say not animals, and that gives you 719,000 studies. And if you say English filter, that comes down to 701,000 trials, which are probably all clinical trials done ever, and are published in PubMed. But then, that's not, you don't want all trials, right? You want trials of kidney transplant. So let's say, hey, why not just put kidney and transplant, which gives you, just transplant gives you 878, put in kidney gives you 907, and you say kidney and transplant, it gives you 158. So you put that and you say, hey, you're interested in angiotensin receptor blocker. So you put ARB and you end up with 176. So that looks like a manageable number. And then you add on that clinical trial filter to it, and you end up with only 4 studies. Wow, 4 studies, it's nice. you can finish your systematic review tomorrow, because you just have to look at 4 studies. And then you look at those 4 studies, none of them are trials of ARBs in kidney transplant. So really, what happened here is that your search was too specific. Kidney transplant and clinical trials may have been too sensitive, but once you put in the ARB, your trial became your search became extremely specific, and you actually, didn't find anything that was useful. So let's go back to the drawing board. Maybe ARBs is not enough. So you add in the individual ARBs. So you put in ARB, you put in ARBs, you put in, and you can look at the last column, which tells you the number of results that you're getting. And they really change. ARB and ARBs gives you different numbers. Angiotensin system blocker gives you a little bit more than doing ARB alone. And then you put in individual names. So, losartan is 9,000, which is more than the ARB numbers were. So olmesartan, of course, is newer, so it has less. And then you can combine them by saying olmesartan or losartan, which gives you 11,000, which gives you both of them. And if you add on the individual names, I've just put in, I think I forgot telmisartan in there. It ends up with about 29,000. And then if you add the filter, if you just add the Pubmed filter for randomized control trial, that gives you 3,181, which is a lot of papers. Again, you don't want to go through 3,181 papers full text. So then, you could add on the other clinical filter that we talked about, and you end up with 8 papers, which again, this was still too sensitive. Sorry, still too specific. And you should go back to the drawing board. The other example here is Ovid. So this is the same search, just for using the ARBs done in the Ovid search engine. So the advantages with Ovid is that you can save your search and you can run your same search. Let's say you did the search in January, and by the time everything is done, you are afraid that a few papers may have been published. So you can say, hey, run the search from January 2020 to October 20th, 2020, and you can find some additional papers and just search those papers. So it's easier to run searches which you have stored within Ovid, and it allows much more of these. It tells you, hey, are you sure you want to use just olmesartan, or do you want to use this angiotensin receptor antagonist or angiotensin type 2 receptor blocker? It's something that came up when I typed a word. So it's smart, and it says, hey, when you're searching for this, make sure you're also searching for that. And there are different options, whether you're using it as a text word or as a mesh heading. So all those things are a little bit more sophisticated in Ovid. And this may seem a little bit overwhelming, right? You're doing something, and are you really sure you're getting everything you wanted to do? So it's if you have access to someone, I would say you walk into a library and see if a librarian who has done these kind of things is available to help. I would strongly suggest, if it's possible, if you have access, that you ask for a librarian, or they're called information specialists now. You ask for someone like that for help. And there are actually guidelines that have come on peer review of electronic search strategies or press. So even if one librarian or you make up a search, you show it to someone else, and they will look at it. They will review your search strategy. They may run it on their own, and they may say, hey, you missed this term, and this is a little bit, this search doesn't seem all that right. Why don't you try this and that? So adding this element of layer of peer review of just your search is the state of the art. This was the actual search that we performed for the review that Atul was saying earlier today, where we looked at ACE inhibitors and ARBs. So it looks, there are 60 lines there, which is not that bad. It's not that complicated. A real search may look really, really long. So that's why. So for example, there is iprosartan that I had missed, as telmisartan. And even for kidney transplant, you can say kidney transplant or renal transplant. You can say kidney transplantation. That will add different numbers. So those kind of factors, or just angiotensin 2, Those kind of things will pick up certain papers that you might otherwise miss. And the whole issue here is, do you want to catch all the fish, or do you want to catch a few fish? Sometimes your search can be so sensitive and broad that you end up with 2,000 papers. So among those 2,000 papers, I'm sure you will have everything, but wading through those 2,000 papers will take you a long time. On the other hand, you may end up with 8 papers, which seems easy, but you're likely to miss something that is important. So the whole key is to try to make a search that is the right balance of sensitivity and specificity. So just to summarize, if you're searching Medline, Ovid and Pubmed search engines are, you can use either of them. Pubmed has, 10 years ago, Pubmed wasn't that great. But now there are a lot of advanced features on Pubmed, some that I showed you, that allows you to do a proper search. If you're using Ovid, just make sure you also search Pubmed, because the papers come onto Pubmed and then they go onto the Medline search engine for Ovid a few days later. So the Medline will not capture papers published in the last 15 days. So to make sure you have got everything latest and greatest, now it's recommended that you also looked at what is called non-indexed citations through PubMed itself. One of the advantages of Google Scholar is that you pick up conference proceedings. So if there was an abstract that was presented at Kidney Week that is going on now, or at the World Congress of Nephrology, or at the ERA-EDTA, and these papers haven't been published yet, Google Scholar is really good at picking up those papers, and then that makes your job a little bit easier. And searching for trials is easy. If you're searching for observational studies, it's a little bit difficult. So there are filters for observational studies, but those filters don't work that well, and they become a little too specific in my experience. So if you're searching for observational studies, try to keep your search as broad as possible is the only suggestion. And be prepared to sift through a lot of data. The next quick section is on study selection. So you may see this kind of figure very often in a Prisma. It's called a Prisma figure based on the Prisma guideline on the reporting of systematic reviews and meta-analysis. So what you see on the top there is, in this systematic review, they found 4,170 papers on Medline, 528 on Central, which is the Cochrane review, and 1665 from Web of Science. Then there were, of course, the other part is additional records identified through other sources. So they don't specify, but good practice would be to specify, how many you found through searching the citations of other papers by snowballing, or experts sent you them, or you found out by looking at reviews, for example. So those kind of all those gets added, and then you have to remove the duplicates. And again, if you're using Medline or Ovid or something like that, it becomes very easy to, when you're adding all those papers together, many of the papers you will retrieve in Medline will be similar to papers you're retrieving from Embase, and if you join them all together, 4,000 plus 4,000 may give you 6,000 and not 8,000, and that's useful if if the software can exclude those. And then you're supposed to review all those papers. So there are different steps of reviewing papers to end up with the small number. And this is very common. You end up, in this case, they started with 5,700 and they ended up with 49. That's not really uncommon. And that's sort of what you want to see, is that so there are those 4 steps. One is you look at the titles. And from the title itself, often it's clear that this study may not have anything to do with ARBs and kidney transplant. So you say, hey, this is out. Then you read the abstracts for, and let's say you started with 4,000, you come down to 1,000. Then you read 1,000 abstracts, and from the abstracts, it's clear that something is, say an editorial, or it's there are still some animal studies that sneak in. It's a commentary, or it's an observational study, or it was not in kidney transplant, or it was some other intervention. You exclude another 900, and you end up with 100 that you look for full text. So these 100, you get all these full text for these 100 papers, and you read all of them, and then you end up with maybe 40 that you're looking at extracting data. And while you're extracting data, also you can realize hey, this paper was written by Dr. Smith, and this one was written by Dr. Jones, but Smith was the last author in the paper by Dr. Jones, and it looks like both studies were done in Liverpool, and both of them have the same number of patients, and they were done in the same similar time period. One of them is reporting patient survival, one of them is reporting graft survival. Oh, they're the same paper, they're the same study. So you can choose the paper that has got the most data, or sometimes you can use both papers together, but it becomes one data point or one row in your study. So you may exclude some studies there. Now, everything that you're doing should be done in duplicate, because there are some subjective decisions that creep in. We keep saying it's systematic and it is objective and all that, but while you're actually extracting data, while you're selecting studies, especially, the decision that I make may be slightly different than the decision Atul made. So the study that Atul was showing was done by him and me. So we did that in duplicate while he was doing fellowship in Ottawa, and I was also a fellow here. Sometimes there are subjective decisions. Oh, is this really valid? And you may say, hey, we should not include that. Or it's usually those decisions are doubtful. So it's good to sit down together and come up with a consensus. If there is disagreement, especially if I feel it should not be included and the other person thinks it should be included, then you make sure you clarify, and it's sort of like double checking whatever work you're doing. So it is really important that the selection of studies, as well as the next step on data extraction, is done in duplicate. And then there are data extraction forms. So previously we used to do them in paper, or there are some databases that allow that. But nowadays it's all moving towards online and software. And again, it's good to keep a record. You may have decided to do one thing and then you added on something else. Make sure you're including everything about the study eligibility also. If you're going through, there are different software for study selection. So you should be able to track the reasons for exclusion of studies. So if you excluded studies after looking at the abstracts, how many were excluded because they were animal studies? How many were excluded because they were editorials or irrelevant? They did not fit the eligibility criteria. And as it's being done in duplicate, all those reasons should be tracked. So when someone asks, hey, why did you not include this study by Dr. Ronco, you can easily say, hey, it was not included for this and this reason. It's there in your database. When you're designing the data extraction form, similarly, make sure you're verifying whether it fits the PICO statement. It's like an additional check. And then you need to put in all the variables that you need for performing the review. Paper forms are of course simpler and they're easier for small reviews. When we did the initial review on ACE and ARB in 2007, we did use paper forms initially, but now we have moved on to electronic, especially when you're looking at comparing things, and you may have more than 2 reviews. If sometimes you end up with 100 papers, so you may say this is too much for just 2. So you may have everything may be done in duplicate, but there may be more than 2 people involved. So that makes it a little bit easier to have electronic forms. So you don't end up with a bunch of papers, but it's something else. So what do I mean by something else is this in the other thing with data extraction is if I do it today and someone else does it tomorrow or 6 months from now, we should end up with the same result. And that's again the systematic process of the systematic review. So it's important to use multiple readers, at least duplicate, and make sure you include all relevant measures in your form, including study quality that we'll come to briefly. If need be, if there is something that is missing, they report graft survival, but it's not sure if they include patient survival, or the way that it is phrased is patient and graft survival, and you want to find out patient survival different from graft survival. It's fine. It's important, in fact, to contact the authors for clarification. It takes some time. It seems like a thankless task, and you evaluate reproducibility of all measures that you're including in your systematic review. And it's very, very common. So data extraction errors, are very common among systematic reviews. This is from Peter Gotche, which showed that 10 out of 27 analysis had serious errors. John Ioannidis has published many systematic reviews, and his own review on the infection fatality rate is full of errors that came out last week. But you really need to be knowing the data to pick up these errors, and they often are missed. And again, doing everything in duplicate helps. Sometimes 10 becomes 100, or 1.0, or a standard deviation and standard errors is a common mistake. So these kind of mistakes can creep in, and you need multiple eyes to look at the data extraction process. So this is one example. So this was an Excel sheet, and we'll share this actual data set with you, which you can then enter into the software as we talked about. So as you can see on the top, this is based on Excel. So you've got the first author, we have got the year, the country. You can have additional factors as funding body, or continent if that matters to you more than the country, language if you've got more than English, or then we had the intervention, ACE, ARB, or direct renin inhibitors, and name of drug, actual name of drug, and how much dose was received. And then we had the control, which again, the control need not be a placebo. It could be placebo, it could be standard of care, but not an ACE or ARB, or it could be nothing. Or it could be an active comparator, like losartan versus amlodipine. So again, this should come back from your original search and your design. And the P-code statement that Dr. Mule talked about is are you looking at only placebo-controlled trials, or active comparator is acceptable? So this column would be based on that, and the name of the active comparator. And then we talked about what kind of study population this was. So in this situation, we are saying, hey, was this all patients with kidney transplant, or patients with kidney transplant who had proteinuria, or patients with kidney transplant who had hypertension? What were the inclusion exclusion criteria for the study itself, to make sure, let's say if you may end up, and these are useful for doing subgroup analysis later on. For example, it may be possible, just to make up an example, is that there may have been some studies with all kidney transplant patients, and there may have been some studies with patients with proteinuria and chronic allograft nephropathy. And it may seem that the effect is greater in those with chronic allograft nephropathy, and less so in patients who had all comers, because they would be at low risk of having any benefit. So that kind of stuff you need to think about beforehand as much as possible, to identify those variables which may be useful again, when you're doing a randomized control trial or an observational studies, there are these covariates. So in this situation, these are the covariates at a study level for your subsequent meta-analysis. And then the key aspects, right? So sample size, how many patients were enrolled in the intervention and the control arm, and sample size enrolled and sample size analyzed, because sometimes these numbers can be different. And then some factors about the population, age and gender and creatinine level, for example, how many years they may have had. And again, this is just a transplant review we are talking about. So these factors are relevant to the transplant setting, but time since transplant. If you are doing the continuous outcomes, then baseline creatinine and subsequent creatinine is really important. On the other hand, if you're talking about categorical outcomes, death, graft failure, retransplant, doubling of creatinine, number of patients who had hyperkalemia, those things then become more important. So all these things should be in your data extraction form. And coming to the last section of today's discussion is on quality assessment. This may seem somewhat dry and boring, but it's really, really important. So evaluating quality of the individual studies. So it can be used as an inclusion criteria. You may say, hey, I'm just going to include the high quality studies. I don't want low quality studies. Or it can help you explain the heterogeneity, which we'll come to next week, is that if you find that, hey, low quality studies show an effect, but the high quality studies do not show an effect. Those kind of things are really useful. And quality scores is different than quality of reporting. And there are certain quality scores and scoring methods. So they have to be very transparent when you're doing them. So issues with quality, for example, especially in trials, how was the randomization done properly? Did everyone have complete follow-up? Was there blinding of patients and clinician? Was it single blind or double blind? And for epidemiological studies, was how did the groups differ in the exposure? Was there adequate adjustment of these covariates? How are the outcomes measured in both groups? Were they measured the same way or differently? All this would lead to some form of selection bias or confounding. So those things have to be considered in quality issues. So one of the simplest scores is called the I think it's pronounced Jadad quality score, which is for a trial. So there are just three elements in this. One is, was the study described as being randomized anywhere in the paper? And was the study described as double blind? Was there a description of withdrawals and dropout? How many patients after being enrolled were withdrew or drop out? And you give one score for each of them. So you give additional point if and if they say randomization, but they don't specify how it was randomized, then they get only 1 point. But if they describe the study as being randomized and then also say, hey, randomization was done as alternate patients, that's obviously not proper randomization. So they don't get any more points. But if they say, hey, randomization was using by generated random numbers, which is appropriate, then, that they get an additional point. Similarly, for blinding, if the blinding was appropriate, then you give them an additional point. And then you take it back if it was inappropriate. If it was alternate numbers, then obviously it was not randomized. So they get 0 in that case for randomization. And so it can range from 0 to 5. And there is an arbitrary threshold of 3 or more being high quality. Now, this was very useful in the early 2000s, but since then, it has been found to be not very sensitive or rather specific to pick up high quality from low quality. So this is of course a citation for that. So the Cochrane group has come up with a different risk. Is called risk of bias. This is of course the logo for Cochrane, and the story for the logo is very interesting. As a brief segue, you see these lines in between, and there is a diamond at the bottom. About the two C's over here. So what does this actually represent is the first meta-analysis done before the Cochrane group actually even formed. This was on steroids and neonatal acute respiratory distress syndrome. And as you can see, there were a bunch of studies. A couple of them were positive, but many others were not positive just because they were small. But when you pool them all together, it resulted in a benefit. And that's the logo which forms, the Cochrane, and the one C is Cochrane, the other C is collaboration turned around, which is the nice logo that the Cochrane group has. So then there is this risk of bias, which has, and again, this is a little bit more tricky. It's a little bit more involved. But this is something that is now the accepted standard for quality assessment in the randomized control trial. So the first time you're doing it, make sure you sit down with someone who has done it before you do it, because some of these decisions are subjective. And this is the example, the link, and we can give you the link, or if you just Google risk of bias Cochrane, it shows up. There's an explanation about how you score. Yes, possible, no, no, or not, not provided. So there are a bunch of options, and they go through all the with very nice explanations. So there's sort of allocation sequence. So it's not just randomization that's important. It's whether allocation was concealed, for example, that's important. So if you know what the next patient is, what do I mean by allocation concealment? If you know what the next patient is going to get, if it's going to be, I know they are ARB, then I might decide to enroll the patient. If I know it's placebo, I may say, hey, I will not enroll this patient. Then that takes away the whole purpose of doing a randomized clinical trial. It's different from allocation. It's different from randomization. It's different from blinding. It's just knowing what the next patient is going to have. which is the allocation concealment. So those things are sometimes not easy to find also, because papers don't give all that information. So you often have to read between the lines to make those judgment, baseline differences, judgment. So what ends up with this is, based on this random sequence generation, allocation concealment, blinding of the participants, and blinding of the outcome assessment, whether outcome data was complete or not, whether there was selective reporting and other biases. There are these 7 domains on which studies can either be green, yellow, or red. So as you can see, on blinding in this example, all the studies are red. So none of them were the patients blinded, which is quite possible. And this kind of, the plus minus that at the bottom left that you see, that kind of figure is appreciated. The software can also generate a figure that you see on the top right, which gives a different feel for the same analysis. So these kind of figures are what you will be able to see and generate and include in your papers when you do a systematic review and the quality assessment. But how to use this, right? So one option is that you exclude low quality studies, and that's usually not recommended and not done. What's more useful is to do a subgroup analysis of the high quality studies separately and of the low quality studies separately. The other thing you could do is also present the quality of the study with your forest plot and analysis. So you include the green and red dots along with your row which has the forest plot, and that's the most. It takes some effort to put that figure together, but that gives a better sense to the reader about what is going on with the quality. For observational studies, there is something else called the Newcastle Ottawa scale. And that has slightly different domains. It talks about the exposure, if there is selection bias, how was the exposure ascertained, was the outcome present at the start of the study or not, are they comparable for a case control study, for example, how are the outcomes assessed, and there are stars, or plus minus, or X and tick mark that you can give for this. So it's a slightly different score, which can go all the way up to 8 or down to 0 for the Newcastle Ottawa scale. And there is another one called the Newcastle Ottawa scale. Again, it's the one that is still accepted, but I think more and more Cochrane has got into this business as well. So they have this risk of bias in non-randomized studies of interventions called Robbins 1, and that will be more popular coming in. There's something else called the grade criteria. So the grade is not really, it's making, when you go to the next step and synthesize the evidence for a guideline, it's important to go through the grade criteria. It's not necessarily important to do it for the systematic review as well. But if your systematic review is going to inform a guideline, that it's important to look at grade and include that as well. So to summarize the quality assessment aspect, for RCTs, the Jadad scale is simple, but some people would argue that it is too simple, and the risk of bias is the preferred tool. For observational studies, there's the Newcastle Ottawa scale as well as the Robbins 1, and I suspect Robbins 1 is going to become more popular with time and take it over. So going on to the software, there are, I don't know if anyone is asking questions, but feel free to enter and put in questions in your chat that will come to. There are a bunch of software that are available. We will give you links to download these softwares where we can have fun. You can play with this in the next week, and we can actually show how these work on the next session. So this is one which is open and free called Open Meta, and this is the Cochrane REV-MAN. So if you go to download REV-MAN, this is the screen you will see. Make sure you click the academic use in that and not the top or the bottom one. And when you click submit, there will be another form that opens up, which requires a lot of other details. It requires name and your institution and what else is going on and what kind of question are you looking at. And it doesn't matter what question you put, but for example, you could use ACE inhibitors in transplant that we are talking about, but you need to go to 2 or 3 steps before you are able to download REV-MAN. But there are other options, right? So if you are a user of Stata, Stata allows doing meta-analysis and doing a bunch of other analysis as well. If you're already into Stata, you can do that. If you're an R user, you can do almost everything you want on meta-analysis using R. It's a little bit harder, as you may know, if you're using R, writing the code and or finding it, but there are plenty of resources online. I personally use this one. It's a paid software though, but it's pretty sophisticated, called Comprehensive Meta-Analysis. If you want, you can download a free trial and play with that as well. If this is something you really want to do in your research career. So just to summarize, there are many software. There's not one that you need to use. REV-MAN is the one from Cochrane. By Cochrane, I mean REV-MAN. It's free. It's widely used and widely accepted. I find it a little bit clunky, and it's harder to do, meta regression and other kind of sensitivity analysis. But it's the one that no one is going to ask you any questions if you publish using REV-MAN. Stata again is it's not free, but if you have if you have Stata already, then it's useful. Again, all these, as well as R of course is free, and it's customizable. It's harder to do some of the sophisticated meta-analysis that you may want to do, which you can do with the other three that I've mentioned below, which are specific to meta-analysis software. It's not worthwhile to pay and getting any of these for now, of course, unless you're going to do a meta-analysis, in which case it may become worthwhile to try to download and use these. So to summarize, a systematic search strategy is really, really important. You should design a search that is the right balance of being sensitive and specific both. Make sure you take help from a librarian or someone who has done this before. Don't venture into doing this, because you're going to do a improper search and will go through a lot of effort for a paper that may be hard to publish. And data abstraction, it can be trickier than it sounds. It requires some subjective decisions. Make sure you have at least duplication and you've got many eyes looking at the data abstraction. The quality assessment, first time you're doing it, work with someone who has done it before. You need mentoring often. And decide what you're going to do with the quality assessment. Often it is just published as quality assessment without any thought about what you're going to do with it. So these are some of the people who have funded me, and I would like to again thank Dr. Rajapurkar for organizing these sessions and having me back to talk about this. Next week, so before I forget, the plan for next week, it's October 31st, which here in Canada in North America is called Halloween, and we will be going out to trick or treat, which probably we won't be with COVID and in the middle of the second wave. But we'll be talking about assessment of heterogeneity and the decision of whether the systematic review should stop at just a systematic review, or we should go ahead to conduct a meta-analysis about fixed and random effects model, how to make forest plot, how to interpret forest plots, how to look at the individual trees in those forests and assess for publication bias. We'll look at some subgroup analysis and sensitivity analysis, as well as meta-regression and cumulative meta-analysis. They are actually, these things are not that difficult to do. They are a lot of fun, and they provide more information than just the forest plot. And of course, as always, I'll end up with saying that if you don't use Twitter, you're missing out a lot. Next week, no, the week after, on our NFJC Twitter chat, we'll be discussing this Fidelio trial that just came out. And if you are someone who listens to podcasts, make sure you listen to ours called Freely Filtered. So with that, I'm happy to have any questions. Oh, and there are some questions in the chat.
Yeah. Swapnil, there's one question each for you and Atul from Dr. Anita. I hope you can see the chat because I lost it, my connection midway through. But Dr. Anita has asked Atul about if the reviewer is going to decide the weight of a study, then doesn't that introduce a bias? So should that be decided a priori? I think you said you're going to talk about weighting next time, but perhaps you could clarify here.
Yes,
Atul?
so that's a good question, and obviously I gave an example of arbitrary weights. But as I said, if the weights can be decided by some scientific manner with some reasoning, then that can be consistent. And there is a way of doing it, and that's what we will discuss next week. There are 2 or 3 ways in which the weights can be decided, and that will be discussed next week. But it is a standard weight, so the reviewer doesn't have a liberty or choice of his own. He has to go by the standard protocol or the standard statistical practice.
The question she's asked to Dr. Swapnil, saying that in the example you gave of 2 authors publishing 2 different papers from the, but with the using the same data, how do you decide the cumulative number?
Yeah, so that's a really good question. So um, the in fact, in this case, let's say in one paper they're talking about patient survival, and in another paper they're talking about graft survival. I would include both papers, but give them one study name, making sure you're not double counting. And what I mean by that is when you do your analysis, you do not mix patient survival and graft survival in the same analysis. So your patient survival will be one analysis, and your graft survival will be a different analysis. So the paper that is describing the patient survival will come in the first analysis, let's say, and the paper that describes the graft survival will come in the second analysis. So, that way they're not getting double counted there. But many people will publish patient and graft survival in the same paper, and that's how it should really be done. You're kind of slicing and dicing it unnecessarily. So for most other papers, it will be Mule et al. With patient survival and Mule et al. With graft survival in both papers. But sometimes it may be Smith et al. In the patient survival and Jones et al. In the graft survival, and both of them actually are papers from Liverpool. So you may decide to label them as Smith and Jones in your meta-analysis, or you can call them the Liverpool study or something like that to prevent confusion. And this is more important in apart from the forest plot. In a systematic review, you have a table 1 where you're describing the studies, where you would say, hey, study 1 was done in England, and there were 28 patients, and this was the study population, this was the mean age. So each row in that table will be each study. So in that case, you make sure that you have only one row for Smith and Jones in your table 1 in your systematic review component. Whereas in your meta-analysis, yes, you're right. The patient survival will be from one study, and the graft survival will be from the other study.
Then there is a question from Dr. Radhika Radhakrishnan saying, can you please actually show how to do a meta-analysis step by step, and how any of your public and how you went about it? So I think maybe either of you could answer that.
Yeah, so that's the purpose of the second session, and we didn't just want to show how to do a meta-analysis without telling you how to do the systematic review component, because if you don't do this component properly, then your meta-analysis is probably going to be biased and flawed. And this may seem unnecessary to some of you. It's like, hey, you just want to have those 5 trials and put them in a software and crunch numbers. But if you don't reach that step of identifying those 5 trials properly, your results will be biased. And there are many examples of that. So what we will do is for the next session, we'll actually, I would recommend you download, REV-MAN is a simple option that you download REV-MAN. We'll email you there's an Excel sheet and which has all the data from the 5 or 6 trials or 7 trials that we included in the AJKD systematic review from 2017. And we'll email it to Aniket, who can distribute it to you. You can look at that and you can decide, how to input numbers. So we will show you that next week. But you can go ahead and try to input numbers yourself and click here and there. It's not that difficult to try to do it yourself. So you can play around with that. And next Saturday, we will actually show you how to do that analysis.
Yeah, I think, sorry, I just interrupting, but I think I agree with Swapnil. And so what we should do is we will send you that file with those studies. I think just pick up maybe just graft survival or patient survival and just look at those outcomes and try and entering those outcomes into REV-MAN and get an output and look at the output. And I think a lot of things will be learned by just doing it, because it's really literally simple to use REV-MAN, and we will demonstrate it next time.
Then there is a, I don't know, maybe I missed part of that because my connection had gone. There's something written by Dr. Preeta Kumar which says forest plot. So if she's there, Dr. Preeta, can you unmute yourself and ask them?
That was the answer for the Cochrane icon. That, I mean, sir was asking regarding the Cochrane icon. So that was when that was.
Yeah, then I think
Yes,
in
yes.
that case, we have come to the end of the questions. So back to Aniket and Dr. Rajapur.
Thank you very much for this very interesting and a rather difficult topic, made rather oversimplified, I would say. Because if anybody wants to get into it, it's not going to be easy. But my question to both of you is that if anybody from the group of participants is seriously interested, can they get in touch with one of you to handhold?
Oh, by all means, for me, and I'm sure Dr. Hiremath will also be very happy to help.
Yeah, and I would actually recommend that you have someone who has done meta-analysis work with you while doing it, because it's easy to do a system. It may seem easy to do a systematic review and meta-analysis, but what I would say is it's hard to do a good quality systematic review and meta-analysis. It's easy to do a poor quality, churn out a forest plot. Once you see the software, in the next week, you will be like, hey, I can do this. So you may say, hey, I'm going to do a meta-analysis now, but stop. Because it's very easy to make. We glossed over some of the possible flaws and mistakes that is possible to do. So you definitely need help. It could be Atul, it could be me, it could be anyone else that who has done these studies. But it's really important to have some mentoring and someone to make sure they're giving you advice about doing the right steps, especially for search. If you have access to a librarian, that's fantastic. If not, one of us could get the search done from someone, and then you do the hard work of going through the 400 studies that come out as a result of that. Well, and Atul mentioned that before, but it's really important. The systematic review that I got involved with in 2007 was because Dr. Noel was doing a trial on ACE inhibitors in transplant, and the need from the granting agency was that before we give you money to do a large trial, show us what has been done before. So we did a systematic review of 22 studies, and we reported that no one had described graft outcomes. They had only described a change in creatinine and change in hemoglobin. So we published that systematic review. Dr. Noel got the money to do a grant and a trial. He did the trial, which reported on graft outcomes, and it was published in the Lancet Endocrinology a few years ago. And by that time, some other people had also done studies on graft survival. So we redid that systematic review, but now looking at patient and graft survival, and showed that whatever it showed. But it's sort of while doing this systematic review, I was a fellow, Atul was a fellow. A is that it helped us understand how to do a systematic review. But B, I read all the papers on ACE inhibitors in transplant. There were 22 papers, there were 22 trials. To do the systematic review, I had to read all the 22 trials. So by reading those 22 trials, you become an expert in that topic because you have read all the evidence that is there. And performing a systematic review then makes you a genuine expert because you know the literature completely. It's a really good start if you want to do rather than say, hey, I will do a study of ACE inhibitors in transplant. First look at what is out there, and that really makes you an expert in the topic.
Well, if I add one thing, saying that when you say read the evidence, that reading also needs to be systematically done for each paper. Is that correct?
Yes, absolutely. Again, finding those papers has to be done systematically, and reading also has to be done systematically. I think there have been some sessions on critical appraisal as well here, right? Those kind of that kind of methodology and frame of mind is extremely useful while you're reading the papers.
Well, thank you very much, both of you, for this excellent session. And also thank you both for agreeing to be mentors if somebody approaches you. As there are no more questions, I think we'll end the session here, and see you all participants tomorrow morning for the session 8, and that is on RCTs. Thank you.
Thank you,
Thank you
everyone.
all.
Thank you. Thank you.